In this lesson, we're going to use the properties of exponents to simplify expressions. The first thing I do to simplify this expression is figure out what to do with this 2 right here so that we can get rid of the parentheses. Whenever I see parentheses, I'm going to use the power law, and the power law says that we multiply the exponents inside the parentheses by the exponent outside of the parentheses. So we've got 5 to the power of 1, a to the power of 3, and b to the power of 1. Whenever we don't have a power listed, it's assumed that it is a 1. So, to rewrite this without the parentheses, we would write 5 to the power of 1 times 2, a to the power of 3 times 2, b to the power of 1 times 2. When we simplify this or use the multiplication shown here, we get 5 to the power of 2, a to the power of 6, b to the power of 2. So now we've gotten rid of these parentheses, we can rewrite the entire problem as 5 to the power of 2, a to the power of 6, b to the power of 2 over 10 a to the power of 2 times b. Once we've gotten rid of the parentheses, we can separate our bases. So when I say separate our bases, I mean that constants, so our numbers, can be put into one set of parentheses. So I'm going to write 5 squared over 10. Our a values can be put into another set of parentheses. So I'll write a to the power of 6 over a to the power of 2. And then our b values can be into another set of parentheses. So here I'm going to write b to the power of 2 over b. Now we're going to solve each of these separate sets of parentheses and combine our answer at the end. So let's start with our numbers. 5 squared is 25 divided by 10. Both of these numbers can be divided by 5, so we're going to put it into the simplest form of the fraction, which is 5 over 2. This is our final value for our numbers. Next, we're going to work with our a values. A to the power of 6 over a to the power of 2. We can use the quotient law because this is division and rewrite this as a to the power of 6 minus 2, since our quotient law says to subtract the exponents. Then we can rewrite this as a to the power of 4, and this is our final value for a. Finally, we're going to go to the b column, and again, we're going to use the quotient law. So we're going to rewrite this as b to the power of 2 minus, and remember, whenever there's no exponent shown, there's an imaginary 1, so we're going to write b to the power of 1 and then subtract that 1. Simplifying this, b to the power of 2 minus 1 equals b. Again, this is b to the power of 1, but we don't have to actually write the 1 because it's assumed. So these are our 3 final values. The last thing we need to do is put all of these bases back together to write our most simplified expression. So remember that we have these two. Well, let's start with 5 to the power of 2. And then if a to the power of 4 is not a fraction, we can make it into a fraction, a to the power of 4 over 1. And same with b over 1. Just like numbers, when variables are not in fraction form, we can put them over 1 to put them into fraction form. Then all we do is multiply across to get our final answer. We can rewrite this then as as 5a to the fourth b all over 2. And this is our most simplified expression here in blue. Let's try one more together. So this one doesn't have any parentheses, so we don't need to start with the power law. So the first thing I'm going to do is just separate my different types of bases. So first I'm going to write my numbers in one set of parentheses. So we're going to do negative 6 over negative 24. Next we're going to look at our x variables. So in this next set of parentheses we'll write x to the power of negative 2 over x to the power of negative 2. Then we'll go ahead with our y's here and here. Y to the power of 4 over y to the power of 6. And finally, we've got our z values here on the end. Z to the power of 8 over z to the power of negative 3. Next, we need to simplify each set of these parentheses. So, starting with our numbers, negative 6 over negative 24. When we have a negative and a negative, our result's going to be a positive, and then we're just going to go ahead and simplify this fraction. 6 divided by 6 is 1, and 24 divided by 6 is 4. That's all we need to do here. We've got a final value for our numbers. Moving on, we see this fraction bar, so that means we need to use the quotient law. The quotient law says that we subtract exponents. X to the negative 2 minus negative 2. Whenever we have two negatives next to each other, we can make that a positive. So I'm going to rewrite it as x to the negative 2 plus 2. Doing this math, we get x to the power of 0. Using the zero power law, we know that x to the power of 0 always equals 1. So we simplified our x expression down to 1. For our y expression, again, here's our division sign, so we're going to use the quotient rule, which means subtract y to the power of 4 minus 6, simplified as y to the power of negative 2. We never want a negative exponent, so we're going to use the inverse power law here to go ahead and get rid of that negative sign. That means that we flip this, so remember this is a fraction, and we can flip it upside down, 1 over y to the power of 2. When we flip it, we change that sign. Here's our most simplified version of the y bases. And then finally our z bases. Again, there's our division sign, so quotient rule, z to the power of 8 minus negative 3. Whenever we have two negatives, we change it to a positive. 8 plus 3. So we get z to the power of 11 when z is simplified. So now we're going to combine all four of these final values to make our final expression. So we've got 1 over 4. We've got 1, which really everything multiplied by 1 is itself, so we can kind of just ignore this one. Then we've got 1 over y squared. And finally we have z to the power of 11. Remember to put it in fraction form, put it over 1. Finally, we can multiply and we end up with 1 times 1 times z to the 11th, so we just have z to the 11th on top, and then 4 times y squared times 1. We don't need to write that one, so our final answer is z to the 11th divided by 4y squared. That's it.